Hi everyone, welcome to the first lesson of Advanced Higher Stats. Today we will be covering the first skill, which is interpreting the exploratory data analysis of univariate data. Sounds a bit complicated, but univariate data just means data with one variable, such as the height of 10 students in a classroom. You will find this skill on page 18 of the 2023 version of the course spec. By the end of this lesson, you should be able to present and understand data in tables, dot plots, box plots, and stem and leaf diagrams, both one-sided and back-to-back. You should know the difference between discrete and continuous data and how each is measured, and you should be able to identify and present outliers. Data can be divided into two categories: discrete data or continuous data. Discrete data involves counting and is normally in the form of whole numbers. For example, the number of subscribers a YouTube channel has, or the number of goals scored in a football match. You can't have 1.3 goals in a match or 34.2 subscribers. Continuous data involves measuring and can be any real number. So for example, measuring someone's height or mass. If someone's height is 6'4" and you're measuring it in meters, you can put it as 1.9 meters, or 1.93 meters, or 1.9304 meters. So in this case, you can be 1.6493 meters tall. In stats, you will be given data presented in a variety of ways, and you should be able to interpret the data given in those forms. So here's an example. Question 8 of 2007, you were given this data. Following a banquet attended by a large number of people, cases of food poisoning were reported and attributed by some guests to the seafood on a menu. A health agency contacted and interviewed a random sample of guests. The contingency table was constructed from their responses. So you should be able to see that 21 people who ate seafood were well, 9 people who ate seafood were not well, 38 people were well who did not eat seafood, and 4 people who did not eat seafood were ill. We should also be able to understand that 30 people ate seafood, 59 people were well, 42 people did not eat seafood, and 13 people were not well. And you should also be able to see that 72 people were contacted. You should be able to present and interpret data given dot plots as well. This is very simple. Here we have the age of 10 students in a stats class. You can see here, one person is still 16, 5 people here are 17, and 4 people here are 18. That's basically about it. You should also be able to work with stem and leaf diagrams. So we have some data here. It consists of 10 students, and each student has their own unique height. And what we can do with a stem and leaf diagram, we can group those heights together and we can try and see any trends. So how does this work? Well, first we need a key, and this shows what this wee line in the middle means. So 15 line 7 is 157 centimeters. But if this data set was for something else, this could mean 15.7 centimeters or something like that. And a back-to-back stem and leaf diagram is just two stem and leaf diagrams joined together with their stems joined. So if we made a stem and leaf diagram for male student height and female student height, and then we combine them, this is what we would get. And then we can see the females are on average are shorter than the males. And here the trend is the majority of people in this class are around 180 something centimeters. Now pause the video and draw a one-sided stem and leaf diagram with the following data. Okay, so how this would work is, let's write the title first. Student mass. And let's see, so the lowest number is 61. The highest is 94. So what we can do here is we can draw a line. We can put 6, 7, 8, 9. Now, let's just draw these lines to separate it. Okay, so how many 60-somethings do we have? We have 61. That's the lowest number. 61. We have 62. No 62. No 63. We have a 64. no 65, no 66. We have two 68s, and that seems about it. Then we move on to 70. So we have a 70, we have a 74, we have a 77. That seems to be it. Now we move on to the 80s. We have 83 and 85. And now we move on to the 90s. We have 94. One quick thing to check to see you have all the mass is counting up how much data you have. So you have 10 masses. You have 4 plus 3 plus 2 plus 1. That makes 10. So that's good. Now, one thing we're forgetting here is the key. So let's draw the key. So we do 6/1 is equal to 61 kg. Okay, now pause the video and draw a back-to-back stem and leaf diagram, now including the gender. Let's start off with a stem. Okay, so for the men, we have 61, then we have 74 and 77, we have 85 and 94. For the women, we have 61, 68, another 68, we have 70, and 83. And then let's not forget our key again. So 60/1 is equal to 61 kg. Okay, so the last thing we need to know how to interpret and present are box plots. So to make a box plot, we need 5 things. We need minimum, which is 157, quartile 1, quartile 2, quartile 3, and the maximum, which is 234. In National 5 Maths, you would have covered how to find quartile 1 and quartile 3 and quartile 2. Quartile 2 is just the median. So first what we have to do is we have to write out all the numbers from lowest to highest. Okay, so that's that done. The quartile 2 will be 183.5, and that means the quartile 1 is 167 and quartile 3 is 189. And now what we do with these data is first we make a scale, and then we draw a line at each of these data points. So one at the maximum, 234, roughly there. One at 189, roughly there. One at 183.5, just roughly there. One at 167, which is there, and one at 157, which is there. And then we combine the quartiles in a wee rectangle, and then we draw a line from the lowest quartile to the minimum and the highest quartile to the maximum. And there we have our box plots. So what does this mean? This means that 25% of the data is in this square, 25% of the data is in here, 25% of the data is somewhere around here, and 25% of the data is somewhere around here. And this also shows us the variance as well. So the box plot we just made has no fences. We can't identify any outliers. Why is that bad? Well, if we do any statistical analysis on it, outliers will drastically influence the outcome, and this can lead to decisions being made which seem to be the right decision, but are actually wrong because these outliers are influencing the outcome. So what are outliers? Outliers are data points which are way too high or way too low relative to the other values of the data set. So how do we decide if a data point is way too high? Well, we create an upper fence. And we do that by taking the quartile 3 and adding 1.5 times IQR. And any data point greater than the upper fence is an outlier. For the lower fence is quartile 1 minus 1.5 IQR. And anything lower than the lower fence is an outlier. So what's IQR? Well, in National 5, you would have covered SIQR. Which is quartile 3 minus quartile 1 over 2. But IQR is just quartile 3 minus quartile 1. So that would mean IQR is 189 minus 167, which is 22. Now we can find the upper and lower fences. So let's do the upper fence first. Quartile 3 is 189 plus 1.5 times 22. And that gives us 222. For the lower fence, quartile 1 minus 1.5 times 22, and that would give us 134. So for a lower fence, our lowest value is 157 right here. So there are no outliers which are lower than the lower fence. So what about the upper fence? It's 222, but our max is 234. So we have one outlier guaranteed. Now we can look through the data set as well. Are there any other numbers above 222? There aren't. So that means there's only one outlier, and that's 234. So how would we draw the box plot now? Well, first of all, we need a new maximum because this is an outlier. So what's the highest number that's under 222? It is 192. That's our new maximum. Now we draw the box plot as normal. So a line for 192. Actually, I'll do this in blue. 192, 189, 183.5, 167, and the minimum is 157. We join up the quartiles, and then we join up the minimum and the maximum like this. And to show that there is an outlier, we will draw a dot in its place. So right here would be a dot, and that would signify an outlier. I also made this box plot in Excel, so you can see the outlier here, 234. We have our new maximum, 192, our minimum, 157. And then for the Excel, they've also put an X on the quartile 2, or the median, but we don't do that in advanced higher stats. Now you should be able to present and understand data in tables, dot plots, box plots, and stem and leaf diagrams, both one-sided and back-to-back versions. You should now know the difference between discrete and continuous data, how each is measured, and you should be able to give examples of each. And you should be able to identify and present outliers when drawing box plots.